just check outside. Hello students, welcome to IMS Gate Academy. See students, as we are inching towards the GATE exam, smart revision plays a very important role in the success of GATE exam. So my dear students, in my previous videos also I used to tell the three mantras. One is the formula sheet, second one we have is the important short notes, and the third one is the key pointers of previous year GATE questions. Definitely these 3 pointers will help you to enhance your preparation for a better rank. So my dear students, don't forget these 3 mantras. Now coming to the IMS Gate Academy, why we should choose IMS Gate Academy? IMS Gate Academy is offering the offline gate coaching at Bangalore Jayanagar Center, and also we are offering the offline gate coaching at Vijayawada near Ben Circle. Now my dear students, let me tell you one important thing, sir. What are the features of IMS Gate Academy? IMS Gate Academy is providing 800 plus hours of gate coaching completely offline, and we are into online and we are also into self-recording sessions also. My dear students, in IMS Gate Academy, if you see the material, we have the subject-wise material. In addition to this, in GATE, we have 3 types of questions. One is NEAT, MSQ and MCQs. So we have the separate exercise book for each material. Like we have a exercise book for every subject, level 1, level 2, level 3 questions, and these level 1 will be given based on the difficulty of the questions. In addition to this, my dear students, when you want to practice yourself and when you want to test yourself, we have the test series where chapter wise, subject wise, advanced level test, multiple subject test and all India mock test, which will be the replica of the GATE environment, how you will write in the GATE exam. And my dear students, the key success for IMS Gate Academy and the key success for the student is the one-to-one mentorship. In addition to this, we also have doubt solving portal where we are able to solve the doubt within 24 hours of time. In addition to this, my dear students, we at IMS Gate Academy YouTube channel are offering all the 6 streams like ECE, EEE, CSE, Civil, Mechanical. And my dear students, when I talk about these streams, all the faculties are from reputed institutes. Myself, Sandeep Adari, I have done my BTech from JN to Hyderabad and MTech from NIT Surathkal with All India GATE rank 192. So this is the brief introduction about myself. And remember, my dear students, if you want to have a feel of the GATE exam, if you are really preparing for GATE 25, then remember, if you are an aspirant from Bangalore, then definitely you should attend the demo where you can essence actually what is the application of the GATE exam and what are the opportunities through GATE exam. So my dear students, I don't want to waste your time and I want to quickly go into the subject. Now see students, here is the subject. What I would like to discuss in this is, today this is my second session on on Geotech. So first one I would like to discuss is the earth pressure. Now my dear students, when I talk about earth pressure, now see students, what do you mean by earth pressure and why do you want to study earth pressure? So see students, see, whenever you are designing a retaining wall or a bridge abutment, basement walls or bridge abutments, earth pressure plays a very vital role. Now my dear students, suppose depending upon the wall movement, depending upon the wall movement, with respect to the backfill, depending upon the wall movement with reference to backfill, earth pressures are classified into, first one is at rest pressure, second one we have is the active earth pressure, and third one we have is the passive earth pressure. So these are the different types of earth pressures we have. One is what, my dear students? Active earth pressure, passive earth pressure and at rest earth pressure. Now see students, what do you mean by at rest pressure? In the name itself, what, sir, in the one of the GATE exams, they have not calculated the at rest pressure. By the definition of the earth pressure, they have asked you, calculate the earth pressure when there is no wall movement, then you have to write it is at rest. Calculate the earth pressure when there is no yielding of soil mass, then you have to use at rest pressure. So let me tell you what is at rest pressure. At rest pressure is nothing but when there is no wall movement or when there is no yielding of soil mass. Sir, what do you mean by the term yield? Yield is nothing but a change in behavior. So in at rest pressure, we are using a concept called elastic equilibrium condition. So based on the elastic equilibrium condition, the at rest pressure K naught is given by the formula K naught is equal to 1 minus sin phi. So the coefficient of at rest pressure is K naught is equal to 1 minus sin phi. What do you mean by active pressure? Active pressure means it occurs when the wall movement is away from the backfill. Suppose if I take this as a retaining wall, here if the wall movement is away from the backfill, if I assume this as backfill, then we call it as active earth pressure. And remember my dear students, when here if you see the yielding of soil mass is due to stretching, or you can say yielding of soil mass is due to tension. Very good afternoon Rajat. Very good afternoon Rajat Shinde. So yielding of soil mass is due to what, sir? Yielding of soil mass is due to stretching or tension. My dear students, when they ask you active earth pressure, they will not tell you calculate active earth pressure. Calculate the earth pressure when the yielding of soil mass is due to tension, or calculate the earth pressure when the wall movement is away from the backfill. Then we have to use the active earth pressure. And remember, see students, in active earth pressure, we will be using plastic equilibrium condition, and Ka can be written as 1 minus sin phi upon 1 plus sin phi. Now my dear students, when I talk about Kp, what do you mean by Kp is passive earth pressure. Sir, the coefficient of passive earth pressure. What do you mean by passive earth pressure? When the wall movement is towards the backfill. When the wall movement is towards the backfill, we call it as passive earth pressure. Now my dear students, in passive earth pressure, the yielding of soil mass is due to compression. So these are very important, sir. Yielding of soil mass. In at rest pressure, no yielding. In active earth pressure, yielding of soil mass is due to tension. In passive earth pressure, yielding of soil mass is due to compression. So here, when I calculate the coefficient of passive earth pressure, Kp can be written as 1 plus sin phi upon 1 minus sin phi. Now, if you are aware of the basic maths, if you see in the numerator part, in these three terms, the Kp value is having the highest term in the numerator. So if you calculate the relative magnitudes of the earth pressure, Kp is greater than K naught greater than Ka. Now my dear students, the application you should know. Sir, what happens actually is, what do you mean by coefficient of earth pressure? Means it is the ratio of, very good Rajat Shinde. Kp can be written as 1 upon Ka, very good. Now see Rajat, what I would like to tell you Rajat here is, the relative magnitudes of earth pressures are Kp is greater than K naught is greater than Ka. Now let me tell you one important thing, sir. Passive earth pressure is used in the design of sheet piles. Because sheet piles means they are something where you will use in harbors, where when a ship impacts that, means to protect the ship, to protect the harbor from the impact of the ships, we will be using passive earth pressure, because passive earth pressure is the maximum. And at rest pressure in basement walls, bridge abutments, we will be applying at rest pressure. And active earth pressure, as you are aware, when in case of retaining walls, active earth pressure is utilized. So this is all about the brief introduction about the earth pressures. We have at rest, active and passive. Now see students, I hope this session, let me tell you sir, this session I hope that you are aware of the basics. Then only you can understand this session, sir. Now let me tell you sir, what is the formula for active earth pressure? Active earth pressure, passive earth pressure, and also at rest earth pressure. So these are all the formulas for cohesionless soils. What are these? These are all the formulas for cohesionless soils. Now see students, if I talk about cohesionless soils, active earth pressure is given by the formula Ka into sigma V, or you can write it as Ka into gamma Z, or you can write it as sigma V can be written as Ka into gamma. If it is passive pressure, it will be Kp into gamma Z. If it is at rest pressure, this is K naught into gamma Z. Now my dear students, let me tell you one thing sir. Here all these are just multiplying with K and K. Sir, what happens is, what do you mean by coefficient of earth pressure? Coefficient of earth pressure means, see students, it is the ratio of horizontal stress by vertical stress. Actually, through the self-weight and all, you will be finding the vertical stress. How this vertical stress can be converted into horizontal stress? Because remember, my dear students, always earth pressure is a horizontal pressure. So our intention in solving the problem is how the vertical stress can be converted into horizontal stress. So just multiply with the K, you will get the vertical stress converted into horizontal stress. So here if I talk about the active force, passive force and at rest force, area of the pressure diagram is nothing but the active force. So my dear students, active force is nothing but half into Ka into gamma z square, half into Kp into gamma z square. Just the coefficients varies, sir. Half into K naught into gamma z square. Now Rajit will ask me, sir, can you give us a free step-by-step procedure where I can solve any problem on earth pressure? So let us try that. Now my dear students, what are the steps involved in solving the earth pressure problem? These steps are generic, and my dear students, these steps will 100% will help you to solve any gate problem. So for that, first you have to calculate the coefficient of earth pressure. What, sir? What is the first step you have to calculate? You have to calculate the coefficient of earth pressure. Sir, suppose it is passive pressure, then you have to calculate passive coefficient of earth pressure. If it is at rest pressure, you have to calculate the coefficient of at rest pressure. If it is active earth pressure, you have to calculate the coefficient of active earth pressure. So respective coefficient should be found out in the first step. Agree, my dear students? Very good, sir. Now the second step is calculating the vertical stress. What, sir? Calculating the vertical stress. Now see, students, this is step 1 is calculate the coefficient of earth pressure. It can be active earth pressure, it can be passive earth pressure, or it can be at rest pressure. My dear students, based on the respective coefficients, you have to calculate the earth pressure. Second one you have to calculate is the vertical stress. Now my dear students, please be careful. What do you mean by coefficient of earth pressure, sir? It is the ratio of horizontal stress to the vertical stress. Agree or not, my dear students? Now, in vertical stress, there is a one note actually. If water table is present, my dear students, you have to write the total stress as effective stress plus pore water pressure. This step is very important, sir. Why you should write total stress as effective stress plus pore water pressure? Sir, when you are multiplying the stress with K, what does it mean is you are converting the vertical stress to horizontal stress. But pore water, according to the Pascal's law, pore water pressure is same in all directions. Are you getting, my dear students? Pore water pressure, Pascal's law states that pore water pressure is same in all directions. Whether it is a vertical stress or whether it is a horizontal stress, it is same. So my dear students, whenever water table is there, you cannot multiply with Ka, Kp or K naught. You have to multiply with only one. Why? Because it is Pascal's law is clearly stating that the pore water pressure is same in all directions. This funda helped us to take K value as 1. Agree, my dear students? And if you see the third step, earth pressure calculation. How do you calculate earth pressure, sir? Earth pressure is nothing but step 1 multiplied by step 2. Agree, sir? First step is coefficient of earth pressure. Second step is vertical stress. Just multiply 1 into 2. You will get the earth pressure. Now see, students, the fourth step is, remember the area of the pressure diagram. What, sir? The area of the pressure diagram will be equal to, what, my dear students? It will be equal to the force. Area of the pressure diagram will be equal to what, my dear students? It will be equal to the force. Now, fifth step is, where does this force acts? This force acts at its centroid. Where does this force act, sir? This force acts at its centroid. Now, with these 5 steps, any problem in earth pressure can be solved, my dear student. Rajat, are you following? So, coefficient of earth pressure, calculating sigma V, earth pressure is nothing but step 1 into step 2. Area of the pressure diagram is force, and force is locating where it will act, the sir, force will act at its centroid. Now see, students, let me tell you another thing. If I calculate the active pressure, for cohesive soils. Cohesive soils is given by the formula Ka into sigma V minus 2C root Ka. So this is the active earth pressure for cohesive soils. What is the formula for passive pressure for cohesive soils? It will be equal to Kp into sigma V plus 2C root Kp. So my dear students, this is the active earth pressure, this is the passive earth pressure for cohesive soils. Very good, Rajit, very good. Now, how do you calculate the active force, sir? How do you calculate active force? Active force is half into Ka gamma z square minus 2C root Ka z. Sir, how I got this value? Sir, what do you mean by force? Force is nothing but the area of the pressure diagram. How do you calculate a body? Sir, if I have an irregular body, how do you calculate the area? Just apply the integration. So, if I apply the integration for pressure, what you will have with respect to the depth? Sigma V can be written as gamma z. What is the integral z? It is z square by 2. What is the integration of a constant? It is into z. So, active force is given by the formula half Ka gamma z square minus 2C root Ka z. Now, my dear students, if I talk about the passive pressure, it will be equal to half Kp into gamma z square plus 2C root Kp into z. So, here what I would like to tell you, my dear students, one is the active force, one is the passive force, another one is the active pressure and passive pressure. So, remember, my dear students, whenever there is a cohesion, you have to take the cohesion part into account. The next one, sir, see this question, like repeatedly I am seeing the question in GATE exam. There is a question called tension crack depth. Let me tell you the funda here, sir. Let me tell you the funda here. Sir, what do you mean by tension crack depth? Sir, if they ask you what do you mean by tension crack depth, means it is the depth at which the active pressure is 0. What do you mean by tension crack depth? It is the depth at which the active pressure is 0. So here, my dear students, active pressure Pa is equal to 0. Now, what is active pressure, sir? Ka into gamma z minus 2C root Ka. So here, you are telling what is z? Tension crack depth. On solving this, Zc can be written as 2C by gamma root Ka. What, sir? Zc can be written as 2C by gamma root Ka. Now, you will ask me, sir, how can you show with me the diagram? Now, see, sir. Sir, here we will have minus 2C root Ka, and this is called Zc, depth of tension crack. What is depth of tension crack, sir? It is the depth at which the active pressure is 0. So, here we have Ka into sigma V minus 2C root Ka. So, my dear students, I am expecting this question. This question is very, very important. So, the depth of the tension crack Zc is equal to 2C by gamma root Ka. Now, how do you calculate the active force after formation of the tension crack? Sir, this is the active force. Before is negative. After formation, it can be positive. So, what is the area of this diagram will be the active force after formation of the tension crack. Now, let us go into that. Sir, see, active force after formation of tension crack. Active force after formation of tension crack. My dear students, this is very important. Active force after formation of tension crack. How do you calculate, sir? Active force Fa is equal to what? Fa is equal to half Ka gamma z square minus 2C root Ka z plus 2C square by gamma. Sir, this point has a valid point, sir. Sir, in GATE 2021, there was a beautiful question, Amma. What is the difference in active force before and after formation? Here comes the common sense, sir. Most of the people, what they will do? They will calculate the active force before and they will calculate the active force after and they will find the difference. But let me tell you one simple logic. Active force after formation of tension crack is increased by a value 2C square by gamma. Sir, see the beauty of this diagram also. Before I am showing small triangle, after I am showing large triangle. That means it is evident and it is clear that the active force after formation of tension crack will increase. So, what is the difference in active force before and after formation, sir? It is equal to 2C square by gamma. Very important term, Amma. Very, very important. Now let us go into the critical height. What do you mean by critical height? Critical height. Sir, what do you mean by critical height, my dear students? Critical height means it is the depth at which the total active force is 0. Sir, please understand what is tension crack depth? It is the depth at which pressure is 0, active pressure. When I talk about active critical height, it is the depth at which active force is 0. Sir, there was a beautiful question asked from one of the student in the offline, sir. Sir, why? Very good, Rajit. Why active force can be 0? Why passive force cannot be 0? Now let me tell you, sir. Sir, when I talk about passive force, sir, in passive, if you see the equation, it is positive. It cannot be 0, sir. If you see the basic maths in that, it cannot be 0. But here there is a term called negative. Some x minus y, both are equal, it will be 0. But if you are multiplying with positive term, it cannot. Sir, I am telling you mathematically. But theoretically, we have a lot of explanation for that. I'll go back and I'll tell you in the latter part. Because it's a quick revision, no? Now, what do you mean by critical height? Critical height means it is the height at which the active force is 0. It is the height at which the active force is 0. What is active force, sir? Half into Ka into gamma z square minus 2c root Ka into z is equal to 0. Now, my dear students, if I calculate here z or critical height, now z will be taken as hc. If you see, critical height can be taken as 4c by gamma root Ka. Sir, it's a quick revision, so I'm not giving in detail, sir. 2 into zc. So it is a critical height is 4c by gamma root Ka or 2 into zc. Sir, see, hc is what, sir? 4c by gamma root Ka or hc is equal to 2 into zc. Now, my dear students, there can be one question here, sir. Sir, you told, Rajit will ask me, sir, what do you mean by critical height? Means you told that it is the height at which active force is 0. But let me tell you, Rajit, what is the practical application? Sir, if you are trying to excavate some soil, suppose this is a borrow pit, sir. You are trying to excavate a soil and you are trying to place the soil here. Without any lateral support, this, whatever the soil which has been excavated, it can withstand. So what is critical height means? The height at which an excavated soil can withstand without any lateral support. Without any lateral support, the excavated soil from the borrow pit can withstand. That is known as critical height. This is the practical application. And what do you mean by critical height? It is nothing but 4c by gamma root Ka. But Rajit, let me tell you another important thing. Hc can be written as twice the depth of the tension crack. Because tension crack is 2c by gamma root Ka. So, yeah, it can be written as 2 into zc. Agree, sir? Very good, very good. Now let me tell you the entire earth pressure. Now, my dear students, let me tell you the entire earth pressure concept in one line, sir. Sir, see, I'll quickly revise in 2-3 minutes, sir. What do you mean by plastic equilibrium? A soil is said to be in plastic equilibrium condition if all the soil particles are near to the failure plane. If all the soil means they are about to fail. Now, depending upon the wall movement, with reference to the backfill, earth pressures are classified into 3 types. One is the active earth pressure, at rest pressure and passive earth pressure. At rest pressure means when there is no wall movement or no yielding of soil mass, elastic equilibrium condition is used. Here K0, coefficient of at rest pressure, K0 can be written as 1 minus sin phi. Okay, K0 can be written as 1 minus sin phi. Agree, my dear student? Similarly, what do you mean by active earth pressure? Active earth pressure means when it is the earth pressure, when the wall movement is away from the backfill. Or you can say the yielding of the soil mass is due to stretching or due to tension. Here plastic equilibrium condition is used. And if you apply that, you can derive Ka is equal to 1 minus sin phi upon 1 plus sin phi. What do you mean by passive earth pressure? Passive earth pressure means when the wall movement is towards to the backfill, Yielding of soil mass is due to compression. Plastic equilibrium condition is used. Kp is equal to 1 plus sin phi upon 1 minus sin phi. And my dear students, you can write here Kp is greater than K naught greater than Ka. And I told you active earth pressure, passive earth pressure is used in case of design of sheet piles. K naught is used in case of design of basement walls or bridge abutments. Active earth pressure is used in the application design of retaining walls. Now let me go into the formulas. How do you calculate the active earth pressure? Active earth pressure is given by the formula Ka into gamma z. And if I talk about cohesionless soils, active force is given by the formula half into Ka gamma z square. Sir, remember always area of the pressure diagram is nothing but the force. Okay, now if I talk about passive force, it will be Kp into gamma z, and Fp, if I talk about the active force, it will be half into Kp into gamma z square. Okay, now these are the formulas for cohesive soils. Now how do you calculate for cohesionless soils? These are for cohesionless. How do you calculate for cohesive? Active pressure is equal to Ka into gamma z minus 2c root Ka z. For passive pressure, Kp into gamma z plus 2c root Kp z. Now see students, tension crack depth Zc is equal to 2c by gamma root Ka. Hc is equal to 4c by gamma root Ka. Now sir, see, after formation of tension crack and before formation of tension crack, the difference in active force is given by the formula 2c square by gamma. This is another, these are the basic formulas. Just go through these formulas. These formulas, sir. Now see students, you have gone through this. Now let me tell you, sir, there can be these kind of questions also. One question is, suppose if you are finding Ka1, there will be diagrams like this also, sir. Okay, when these diagrams will be like this and when it will be like this. Suppose if Ka1 is greater than Ka2. Okay, suppose we have two soils, sir, two soil stratas. One is having Ka1 and other one is Ka2. Okay, if Ka1 is greater than Ka2, then the pressure diagram will be like this. Okay, sir. If Ka1 is, in this case, if Ka1 is less than Ka2, Ka2, if Ka1 is less than Ka2, this should be the diagram, pressure diagram. Why? Because to understand this, for calculating the forces and everything, you should have an idea on this. Okay, sir. Now see students, now let me go into the next topic, sir, that is stability of slopes. When I talk about stability of slopes, sir, why, sir, suppose you have seen recent in Uttarakhand, there was a people when they are building some like tunnel and all, some people have been struck. And if you see in Himachal, Uttarakhand, where there is a lot of hilly areas, you are able to see lot of landslides. So my dear students, as a civil engineering student, what is our agenda is, whenever huge landslides are happening, what could be the reason for the landslides? Whether it is a seepage force, whether it is an earthquake force, whether it is a uplift force, which force has made the soil to have a slope failure? That we have to investigate. That is the actual where the geotechnical expert will go into the site and understand the behavior of the soil. But in stability of slopes, how the slope can be made into stable, where you can avoid the landslides and have a better living of life there. So my dear students, when I study about stability of slopes, these are the most challenging things. Now in slopes, we have two types of slopes, sir. One is the finite slopes and other one we have is the infinite slopes. What are the different types of slopes we have? My dear students, we have two types of slopes here. One is the finite slope and other one is the infinite slope. So what is actually finite slope? A slope length is limited, then we call it as finite slope. If the slope length is unlimited, then it is infinite slope. So my dear students, in finite slopes, you will observe a behavior of rotational failure. Sir, you might have observed a failure called rotational failure. And if you talk about infinite slopes you will observe a translational failure. You will observe a translational failure. So my dear students, let me tell you one important thing, sir. If you are a student from Bangalore or Vijayawada, we are running the offline gate coaching centers at Bangalore at Jayanagar office and Vijayawada near to the bench circle. If you want to have an essence of the gate, my dear students, let me tell you, everyone please don't think about gate has an opportunity to get into PSU, through gate we can get into MTech. But remember, if you are an engineering student, what you have done in these 4 years, if you want to really have an application oriented learning, and these 4 years if you want to be accountable, and these 4 years if you want to be in a proper way where your application can be applied in the industry, then definitely you should have a gate coaching, means gate preparation I should say, because see, these small application oriented learning will help you in the growth of the company. Suppose if you want to reach heights in the company, your core knowledge should be very strong. So to achieve this, definitely gate will help you. So that's why I'm more stressing on these parameters. Now let us go into the two types of slopes. One is the finite slopes and the infinite slopes. In finite slopes, we have rotational failure, and infinite slopes, we have translational failure. Now see students, how do you calculate the factor of safety for translational failure? Sir, what do you mean by factor of safety? How can we avoid this slope? That is the only intention, yes or no? So my dear students, when I talk about the factor of safety, for translational failure, the factor of safety for translational failure can be written as shear strength upon shear stress. What is the factor of safety for translational failure, sir? It is nothing but the ratio of shear strength upon shear stress. What is the ratio? It is defined as the ratio of shear strength upon shear stress. For translational failure, my dear students, this formula is very important. So when I talk about this definition, sir, actually shear strength is a function of effective stress. So we will have the formula shear strength also. But let me tell you, the factor of safety is given by the formula. Factor of safety is equal to C plus gamma z cos square I into tan phi upon gamma z cos I sin A. Gamma z cos I sin A. Now let me tell you what do you mean by I, sir. Here, my dear students, let me tell you what do you mean by I is nothing but the angle of infinite slope. What do you mean by I, sir? I is nothing but the angle of infinite slope. What do you mean by I is nothing but the angle of infinite slope. So my dear students, when I talk about this angle of infinite slope, sir, see here, what do you mean by C? Cohesion. Now what do you mean by gamma? Gamma is nothing but the unit weight. So this is the formula for shear strength upon shear stress. Now see students, if I talk about the factor of safety in case of seepage, sir, you can say 2 to 3 times it was asked in gate exam. This is also very important formulas. Sir, I can suggest you one thing. After writing the gate exam, just see my videos. When I say something important, you will find in and around that. I will not say 100% accurate, but you will find. So the factor of safety for seepage is given by the formula gamma dash upon gamma sat into tan phi upon tan I. What's that? Gamma dash upon gamma sat upon tan phi upon tan I. This is the factor of safety formula for which type of soils, sir? For which type of soils, my dear students? This is the factor of safety for the factor of safety for cohesionless soils in case of seepage. So why? Because actually now, my dear students, when you talk about the effective stress, how do you calculate? In case of seepage, water table effect will be there. So gamma dash submerged into it will come into picture, and the total stress will be calculated using gamma set. That is the reason this term has came into picture. I hope you are clear. Now see, students, when I talk about the factor of safety for rotational failure, what, sir? When I talk about the factor of safety for rotational failure. So when I talk about the factor of safety for rotational failure, what is the formula we have, my dear students? Factor of safety for rotational failure is given by the formula resisting moment upon, it is given by the formula resisting moment upon driving moment. What is the formula, sir? It is given by the formula resisting moment upon driving moment. So here when I talk about the factor of safety for rotational failure, it is defined as the ratio of resisting moment upon driving moment. Now see, if I talk about the factor of safety here, if you talk about phi u is equal to 0 analysis, sir, in phi u is equal to 0 analysis, the failure surface, sir, you can ask me what is translational failure. It is a failure occurs at some depth parallel to the slope, sir. Whereas rotational failures occurs along a curved surface area, right? Because that is the reason rotation will happen. So when I talk about phi is equal to 0 analysis, the failure surface is assumed like an arc of a circle, and the weight, self weight. Always, sir, see, when you are falling from a height, the self weight will drive you, and the resisting force will be your either friction if you are walking on a hill or anything. Similarly, here the resisting force will be due to shear strength. So when I talk about the factor of safety for phi is equal to 0 analysis, the factor of safety is given by the formula C into LR upon W into X bar. So this is the very important formula. What do you mean by C here? Cohesion. What do you mean by L? L is nothing but the length of the arc. What is the length of the arc, sir? If this is radius R, if I consider this as radius R and this is theta, what will be the length of the arc? Length of the arc will be nothing but equal to R theta. Yes or no, my dear student? So the factor of safety for phi is equal to 0 analysis is CLR upon W into X bar. Always remember, driving moment means what, sir? Force into distance or force into perpendicular distance. So the driving moment is due to the weight. So weight into the X bar. X bar is the centroidal distance and L is the length of the arc and R is the radius. Sir, why I have taken C only here? Actually, shear strength is a function of C plus sigma dash tan phi. But what you have told in the problem, in the method, phi u is 0. As phi u is 0, this entire term will be 0. So shear strength will be equal to cohesion. That is the reason. So my dear students, the factor of safety for rotational failure is resisting moment by driving moment. Resisting moment will occur due to shear strength. I hope you are clear. Okay. Similarly, we have Swedish circle method. What, sir? Swedish circle method is also known as method of slices method. Swedish circle method is also known as what, sir? Swedish circle method is also known as what, my dear students? It is also known as method of slices. Here the factor of safety, if there is seepage, the formula will be Cl plus sigma n minus u tan phi upon sigma t. Sir, see, let me tell you, what is sigma n? Sum of normal forces. What is sigma u? Sum of neutral forces or pore water. What is sigma t? Sum of tangential forces. Why? Because here also the failure surface will be arc of a circle. Now, my dear students, if I consider here weight will act downwards. Here you will have a normal component, you will have a tangential component. But remember, my dear students, normal component will pass through the center of rotation. Hence, normal component will not cause driving moment. Only the tangential component will cause driving moment. That is the reason I write sigma t. What is sigma T, sir? Sigma T is nothing but the sum of the tangential forces. And the resisting force will be only the normal moments. So I have written that. I hope you are clear. Now see students, similarly we have another method called Bishop's method. What is Bishop's method is, you can say Bishop's method is the most accurate method. What, sir? Bishop's method is the most accurate method. And how do you calculate? Sir, the funda is same. The factor of safety for rotational failure. Sir, see, what happens in Swedish circle method is, suppose here if this is a failure surface, we consider in the form of slices. But here the forces are not considered between the slices. But in Bishop's method, forces between the slices are considered. That is the reason this is the most accurate method. They can ask you why Bishop's method is the most accurate method is, the forces between the slices is considered. Hence, Bishop's method is the most accurate method. Here the factor of safety is given by the formula C plus sigma tan phi upon Cm plus sigma tan phi m. Sir, see, what do you mean by mobilized? Mobilized cohesion and mobilized friction. Now let me tell you one important thing, my dear students. When I talk about, as you are considering the forces, definitely there will be a change in cohesion and friction. So mobilized means you can say simple words by change in cohesion and change in friction. Okay, sir? Is this clear? Now what do you mean by factor of safety? C plus sigma tan phi upon C plus sigma Cm plus sigma tan phi m. Now if they ask you with respect to cohesion only, then you can write it as C by Cm. If they ask you with respect to friction only, you can write it as tan phi by tan phi m. Okay, my dear students. Now similarly, what I would like to tell you here is, there is the radius of friction circle. They can ask you this. Sir, this can be a 1 mark question or anything. The radius of friction circle. The radius of friction circle is nothing but equal to r sin phi. What is the radius of friction circle? The radius of friction circle is nothing but r sin phi. Okay. Now let me tell you, you are aware of radius of friction circle. There is another concept called stability number. Stability number is nothing but C by Fc into gamma into H. The reciprocal of stability number is known as Taylor stability factor. Sir, when you are finding the critical height and all, stability number will help you. Actually, sir, usually if you see the other codes, actually there will be a graphs for stability number. Through the graphs, you will be having the stability values, because it depends upon the 5 values, and based on the 5 values, you will be calculating stability number. But as part of the gate, they will give you the stability numbers directly, sir. So stability number is given by the formula C by Fc into gamma into H. Okay. Now see students, what do you mean by seepage or seepage pressure? Sir, what do you mean by seepage pressure means? It is the pressure exerted by a soil mass, or you can say it is the pressure exerted by the soil on it is the pressure exerted by water on a saturated soil mass is nothing but seepage pressure. Okay, sir? Seepage is a very dangerous sign, sir. Sir, see, in seepage you might have come across quicksand condition. Sir, if you see in English movies or anything, you will see a diamond shape and saying that in red color, danger sign. So what actually is a quicksand condition is, if upward seepage pressure becomes equal to the submerged unit weight, then the soil means what happens is, then the effective stress will be equal to 0. In this case, the soil will lose all its shear strength. That condition is known as quicksand condition. Are you getting me, sir? If the upward seepage pressure becomes equal to the submerged unit weight, the effective stress reduces to 0 and it loses its shear strength. Sir, most of the people should know basic at least. By looking into the name, you will think that quicksand means it is a type of sand. Never ever think that quicksand is a type of sand. It is a condition where it is observed in cohesionless soils. Are you getting me, sir? Sir, see, if you take about shear strength is C plus sigma tan phi, right? Quicksand condition is observed only in cohesionless soils. Why? Because even though the effective stress is 0, shear strength will not be 0. It will be equal to cohesion. That is the reason quicksand is a condition which is observed in cohesionless. Cohesionless means C0. It is not observed in cohesive soils because even though the effective stress is 0, shear strength cannot be 0. It will be equal to cohesion. Now, what I would like to tell you is the hydraulic gradient at quicksand condition is known as critical hydraulic gradient, and IC can be written as G minus 1 upon 1 plus E, or you can write it as gamma dash upon gamma W. This formula is very important in case of quicksand condition. What, sir? If the upward seepage pressure becomes equal to the submerged unit weight, the soil loses all its effective stress reduces to 0 and the soil loses its shear strength. It is a condition which is observed in cohesionless, and critical hydraulic gradient is given by this. Now, what do you mean by piping? You might have come across a condition called piping. Sir, what do you mean by piping means if seepage is taking place below hydraulic structure, sir. If some seepage is happening below hydraulic structures, there exists a gradient which is more than the critical hydraulic gradient. Are you getting me, sir? So, in this case also, the shear strength will be reduced to 0. There will be existing a gradient which is more than critical, which cannot be very harmful. So, that is the reason. How can you avoid piping is, factor of safety for piping is given by the formula IC upon I. What is the formula, sir? Factor of safety for piping is given by the formula IC upon I, where IC represents the critical hydraulic gradient and I represents the actual hydraulic gradient. Now see students, the quantity of seepage is given by the formula KH into NF by ND. What, sir? The quantity of seepage is given by the formula KH into NF by ND. Now see, what do you mean by K? Permeability. H is the head causing the flow. NF by ND is known as shape factor. Now see students, if I take about the flow net, what is a flow net is a group of, it is a combination of streamlines and equipotential lines. What is a flow net? It is a combination of flow lines and streamlines. When I talk about flow line, it is nothing but a streamline. It is the line along which a water particle travels. What is a equipotential line? It is a line joining points of equal total head. Remember, sir, let me tell you, in soils, velocity head is neglected. This is very important now. In soils, total head and piezometric head will be same. Because a soil cannot move like a water, sir. If you are allowing the soil to flow, it cannot move like a water. So, in soils, velocity head is neglected. And remember, sir, the space between two flow lines is known as flow channel. And remember, the space between two adjacent flow lines and two adjacent streamlines, this is called as field. So, there might be properties of the flow net which says that you can say here the properties of the flow net means two streamlines never meet each other, two equipotential lines never meet each other, the fields are almost in the shape of squares, and you can say the drop in head in each flow channel is almost same. Like that we have some properties, and this is all about the quantity of the seepage and all. Sir, see students, I hope you have enjoyed this session. See students, again I am telling you, IMS Gate Academy is offering the online gate coaching, offline gate coaching, and also recorded lectures. But my dear students, in offline gate coaching, we offer 800 plus hours of gate coaching. Here we provide the subject-wise material, and we provide the exercise book which contains level 1, level 2, level 3 questions, which includes MCQs, NATs and MSQs. And also I would like to tell you one important thing, sir. We are providing the All India mock test series in addition to the chapter test, subject test, advanced level test, and also multiple subject tests. And we have the important features like one-to-one mentorship and also doubt solving portal. We are the only institute which are offering offline gate coaching in Andhra Pradesh and at Vijayawada near Bench Circle. And if you want to visit our offline center in Bangalore at Jayanagar office, near Jayanagar office, we have the offline center. Now coming to the things, students, when I talk about these things, sir, see in geotechnical, where we can expect questions are from either from properties of soil, compulsory questions it's my guess, sir, properties of soil. Another one is seepage, means permeability, seepage analysis and all. Next one is consolidation. Earth pressure and pile foundations. Sir, there are some other also important topics, But to my knowledge, these are very, very important topics. Means if you are giving extra time for geotechnical, if you see in geotechnical, there will be a weightage of 10 to 12 marks. If you want to give extra weightage for these topics, sir, please stress on this. Because, sir, see, if my guess is correct, actually IISc Bangalore is an institute where lot of research has been happening in water. So we can expect questions related to hydrology irrigation, even in environmental we can expect, and also in fluid mechanics, and also in geotech where the seepage kind of thing, consolidation, where the topics are related to water. It is my only, it's a wild guess, sir. You cannot say that, sir, you have told these questions are. It's my wild guess, that's it. So it will add value addition to you. That is my intention. I hope you have enjoyed this session. Students, if you are looking for other streams also, we at IMS Gate Academy YouTube channel providing all the updates in the Telegram group. So you just click on the Telegram group and join the session. I hope this session will create an awareness on the earth pressure topic and stability of slopes. Thank you.